Hello and welcome back to Pure Science Education. Today we will be looking at how to calculate ideal gas equation in an A-level exam. If you look at gas particles, they're all around us and we can feel them depending on the temperature. There is a relationship between pressure and volume, and we're going to look at what ideal gas equation is. So ideal gas equation has got this formula here. So we're going to look at what these entities are. But before we do that, we're going to look at one particular relationship. So if I was to do pressure times volume, that gives me a K, which is a constant. Now, this constant will only work if the temperature stays constant and we have the same amount of gas particles. And this equation here is Boyle's law. So before the ideal gas equation was created, this original equation was created beforehand, and then it was taken further to change into ideal gas equation. There are a number of factors if we look at them. If you decrease the volume, the pressure will increase. If you increase the temperature, the pressure also increases, and that's because particles have more kinetic energy and they can move faster. So what does a typical exam question look like? So let's look at that. So calculate the volume in liters of a party balloon filled with 0.22 moles of helium to pressure of 120 kilopascals at 5 degrees centigrade. So this is a typical exam question, and now for what I need to do, first of all, I need to highlight all the key information. So I need to calculate the volume in liters, which is the key information. Then I have been told that I have got 0.2 moles of helium, and the pressure is 120 kilopascals, and the temperature is 5 degrees. So that's all the information that has been given to me. So let's process the information. So to start off with, I know moles of helium gas from the question, which is 0.22 moles. Then I need to work out the pressure, and for the pressure I need to change it into 1 atmospheric pressure, for which I need to do a calculation. And to do the calculation, I've got 120 kilopascals. If I was to then times over 1 atmospheric pressure and divide by 101.25 kilopascals, the answer is 1.19 atmospheric pressure. ATM is what we write it down. The next entity I need to know is temperature of helium gas, and again I need to change it from a degree centigrade to Kelvin, and 1 degree centigrade is equal to 273.15 Kelvin. I have been given 5 degrees, therefore I'll have 278.15 kelvins. So let's link all this information together. And the other thing we have been given is the R, which is a constant, which is 8.314 kilopascals per liter per mole per Kelvin. So if I was to then put the equation together, originally I had PV equal nRT. I'm going to rearrange my equation because I need to work out the volume. Becomes nRT divided by P. And if I was to put in the different values, volume is equal to 0.22 moles times 0.0821 liters atm Pascal, Kelvin and moles, multiply by my temperature 8.1 Kelvin, and finally the pressure is 1.19 atmospheric atm. And the answer, if I was to resolve all of this, let's put the units in here. So over here, and if I was to resolve all of these, then the final volume is equal to 4.22 liters. If you like the video, please subscribe. Thank you.